some output or some quantity of interest. So back to my example. What's the example? I want to vary the volume of the reactor and see how this affects the conversion. Okay? So these are the two variables I'm looking at. Okay, so let's specify in the vary tab, it says manipulated variables. Okay? Let's introduce variable 1 as the volume. Okay? So variable 1, what type of variable is it? It's what's called a block variable. So in this drop-down menu, you go to block variable. Block variable means a variable associated with a unit, not with a stream. So a flow rate, a temperature, pressure, composition, these are all stream variables. But things like volume, area, number of stages, okay, these are block variables because these are associated with a unit. So for our CSTR, you know, the manipulated variable we're going to choose here is the volume. It's a block variable. Aspen will ask you which block. The flow sheet has several blocks. So we're going to pick the reactor. And what is that variable? Here you need to specify that it's the volume. Okay? Here you have to be careful. If you look at this list, there's this here that says react-vol. You may assume that this means reactor volume. Okay? But then if you look at this help, it will explain, but this is not actually the reactor volume. This is the volume of the phase. Okay? But the right choice here is this variable, VOL. This is the specified reactor volume. And the units can be anything. You have the freedom to choose the units, but since we specified them in the block itself in cubic feet, we're going to stick with that. All right, so now Aspen wants you to specify what is the range of volumes that you want to search over. Okay? Like what is the smallest reactor you're thinking of, what's the biggest reactor you're thinking of, and it's going to scan this range and give you maybe the volume that has the best conversion or best whatever. So let's put in some numbers. Let's say 50 cubic feet is the smallest and 200 is the largest. So in a sense, you're asking Aspen now to search for the best volume between 50 and 200. You can change that range. If it's not, the results are not satisfactory, you can make that range larger or smaller. Now, how many, of course, Aspen is not going to check every single point. It will ask you how many points do you want to check, or what's the increment. Let's make it an increment of 10. This means Aspen will check or will run a simulation for a volume of 50, 60, 70. Of course, if you pick a large increment, you save the computational time because you have only a few runs. But if you want a good result, you probably want a small increment, okay, so that you catch the optimum if it exists. All right, so this tab here is the tab where you specify the manipulated variable and the range, okay? The next tab is where you define basically the output, okay? One thing about Aspen is if you look through the variables that Aspen recognizes, conversion is not one of them. Okay, if you look at results in a typical Aspen simulation, you'll see temperature, pressure, flow rates, mass fraction, mole fraction, you name it. But conversion is not a recognized variable. Okay? So we could look at the production rate, if you will, or we could look at the reactants flow rate and so on. But usually we want to work with conversion. Okay? Because we know from the CSTR design equation that there is a direct linkage between the two. So Aspen allows you to define variables. Okay? So for example, what is conversion here? Remember, A is methanol, and B is acetic acid. If you go back to the data, the data reported conversion in terms of methanol. So what's conversion? It's the amount of methanol in the feed minus the amount of methanol in the outlet stream divided by methanol in the feed. Right? This is what conversion is. The conversion of methanol is the molar flow rate